1, 2, 3, 4, 5 are the vertices, and is 1, 2, 2, 3, 3, 4, 4, 5. Again, 5, 1 is joined so that it is a closed graph. That's why we call cyclic graph. Now, from this cyclic graph, we can make some subgraphs. Subgraphs which is not cyclic, but containing all the vertices, all the nodes. Then in this way, eliminating any edges, we can make a new graph which is not connected, not cyclic. Cyclic graph is called a tree. Now, among the tree also, the tree which contains all the vertices, all the nodes, is called a spanning tree. Now, from this cyclic graph, how many spanning tree can we form? Let's discuss it. Okay, how many spanning tree can we form from this cyclic graph? It's my question. Okay, for example, I'm going to try some spanning tree. This one, in which the edges 5, 1 is deleted, then containing all the 5 nodes and nodes. Then we have subgraph of the given cyclic graph, which is spanning tree, which is called a spanning tree. By the definition of a spanning tree, this graph is a spanning tree since it contains all the vertices, and it is not cyclic. That's why it is a spanning tree. Likewise, we can make a next spanning tree, eliminating this 1 to edge. Okay, likewise, how many spanning tree can we form? Is 5
n minus
nodes
1 or
and 5 nodes, then containing 5 edges, we can complete the cyclic graph. But eliminating one of them, we can form a spanning tree. That's why since out of 5 edges, taking 4, we can make a different spanning tree. This means to count the number of spanning tree, we can use the combination technique of counting. That is 5C4. 5C4 number of spanning tree we can from here. We can form a spanning tree 5C4. That is, out of 5, we have to take 4 edges. That's why we can get 5C4 spanning tree, that is, which is equal to 5. In this way, we can make so many spanning tree according to the structure of given graph. Now, if we assign weights for the cyclic graph like this, then it is called weighted cyclic graph. From this weighted cyclic graph also we can form different spanning tree, different weighted spanning tree. Now from this spanning tree, we can, since it is weighted, that is value is given, that is cost is given, then how can we find the minimum cost, that is the lowest cost spanning tree? Since all the spanning tree, since from all the spanning tree, one of the spanning tree contains one of the spanning tree have minimum cost, then how can we determine that which spanning tree has minimum cost? Okay, for this some algorithm, we already developed algorithm we can apply. One of them is Prim's algorithm. Okay, Prim's algorithm, according to Prim's algorithm, first of all, we have to take the lowest cost, lowest value arc, which in my example I have shown there 2, 3. The arc 2, 3 as the lowest cost, lowest value assigned, therefore, which is 6. Therefore, according to Prim's algorithm, first of all, we have to take the lowest one. And from for the second edge, we have to take the lowest cost containing arc, which are initiated, started from these two nodes, that is from 2 or from 3. From 2 and 3, among them, the lowest one we have to take. The lowest one is the arc 3, 4, whose value is 10. Okay. After this second step, we have 3 nodes now. Among the 3 nodes, we have to take the in the third step we have to take the list arc, arc which is in my example, which is arc 4, 5, whose weight is 8. Okay. Likewise, now we have 4 nodes. Among the 4 nodes, we have to choose the next arc which contains the least value, least weight, that is least cost. In my example, it is the 5, 1 arc whose weight is 12. In this way, we have all the nodes having different weights. Now, sum of all the values, all the cost of this spanning tree is minimum cost spanning tree, whose minimum cost is 36. Yes, the sum of all the edges, all the cost is 36. In this way, we can derive the minimum cost according to this primed algorithm. Yes, likewise, there is next algorithm also, which is Kruskal's algorithm for the same minimum cost. Okay, according to Kruskal's algorithm, we have to take the arc which has least cost. In my example, it is 2, 3 node, 2, 3 arc whose cost is 6. And in second step, according to Kruskal, in the second step we have to take the next arc whose cost is least one. Okay, in the example, the least one is the arc whose cost is least one is 4, 5. That is its value, its cost is 8. In this way, in the second step, we have this one. And in the third step, again, we have to take the arc whose value, whose cost is least one again. Remaining of them. Okay, in my example, I have taken the arc 3, 4, whose value is 10. Yeah, in this way we have according to Kruskal's algorithm, we have 4 nodes 8. Now for the fifth one, we have to take the remaining arcs, that is whose value is least of the remaining arcs. Okay, which is 5, 6 arc, and its cost is 12. In this way, again, we have the second technique of the minimum for the minimum cost, which is Kruskal's algorithm. Its value is again the 36. In this way, according to Prim's algorithm and Kruskal's algorithm, we can find the minimum cost spanning tree. Yes.
Anil sir.
Yes, sir.
Is it 5? Is it 5, 6 or 5, 1?
Okay, 5, 1's the last one. Okay, I did mistake there, sir. Thank you for the reminding this one, sir. Okay.
Okay, sir. Thank you. Continue, sir. Yeah.
Okay, in this way, I have completed both algorithm to find the minimum cost spanning tree. Yes, sir. Now, if you have any inquiry, then you can put some questions, sir.
Sir, can you repeat once the previous one?
Previous one means, sir, Kruskal, sir, primes.
Primes or prims, prims.
As a Prim's idea, Prim's algorithm.
Yeah, you have.
Okay,
Yeah,
in
yes, sir.
Prim's
Repeat only once. Yeah.
algorithm, yes,
Yeah.
this one. First of all, we have to choose the least cost arc. This is the first
Yeah.
step. And in the second step, we have to choose the next arc whose value is least but started from the given node in the first step.
Either
That
from
is,
2 or 3.
yes, either from 2 or either from 3. But the arc which is start from 2 is its arc value, cost value is greater than the arc started from 3. That's why the least one is starting from 3. That's why it is taken this one 3 for as well as
Yeah.
10.
Yes, sir. Yeah. Yeah.
Okay, now from in the cyclic graph that I had taken before is there are no arc from 2, 3 and 4. ये तीनटेबाट arc छ, but among them the arc starting from 4 is least one, which is 4, 5, whose value is
Yeah.
8.
We have to take from ends. Yeah.
Yeah, ends.
Node.
Ends, or we can take any one of them, not only end,
Yeah.
but value
Both
or
one.
cost must be the least one.
Yes. Good, sir. Yeah.
Okay, likewise, at the last, we can take, we have the 4 nodes 2, 3, 4, and 5. But among all the 4, the node, the arc whose cost is least one, we have to choose. The arc which starts from 5 is the least one. Therefore, it is 5, 1 arc we have chosen, and its value is 12. In
Yeah,
this
cost
way,
is
we
there.
have, yes, in this way we have completed the spanning tree. Now this spanning tree is the least or minimum cost spanning tree. Since we can have many spanning trees, among them this one is the least one. In this way we can determine the least or minimum cost spanning tree. This is according to Prim's algorithm.
Sir,
Spanning trees. Yes, sir. Spanning trees containing all vertices, but not the cycle, sir.
And not cycle. Without cycle containing all vertices is spanning tree.
Oh, good, sir. Thank you. Yeah,
Sir.
best revision.
Okay, sir.
यो प्रिन्स अल्गोरिदम र आर्को दुईको अल्गोरिदमको त सर यो भर्टेक्स र त्यसको चाहिँ त्यसको त्यो मिनिमम कस्ट त सेम छ है सर हैन र
कुन चाहिँको भन्नुभयो सर?
त्यो प्रेम यो प्राइम्स अल्गोरिदम छ नि सर यसमा पनि त नोट्सहरु भयो हैन त्यसका एजेसहरुको कस्टहरु छ नि वेटहरु
हजुर
यसमा पनि 36 नै आएको छ 2 देखि 3 को 6 छ 10 छ आर्कोमा पनि यही नै छ हैन र सर
यही नै छ सर यसमा तर यसको सेकेन्ड स्टेप फरक छ हेर्नु सेकेन्ड स्टेप फरक छ मतलब उसले चाहिँ मिनिममबाट मात्रै स्टार्ट गर्ने भन्छ हैन
हजुर
यो क्रुस्कल्सको चाहिँ जुन